In this video, let's continue exploring the infinite geometric series and learning how to determine when they actually converge to a finite sum. In this series, starting from the second one, each term contains an unknown variable x, and we are required to solve in what range the x could be so that the series will converge. We know that a geometric series only converges if the absolute value of the common ratio is less than 1. We can write it as the absolute value of r is less than 1. So this is the converge condition. For a geometric series. Here, these two vertical lines means the absolute value. For example, the absolute value of minus 2 is 2. And the absolute value of 2 is also 2. So essentially, the absolute value ignores the negative sign if there is one, and leaves the positive number unchanged. So it gives us the magnitude of that number. So how does this converge condition have anything to do with finding the range of x? Well, the common ratio r is actually contains the variable of x. Then if we substitute the value of r into this inequality, we establish an inequality that contains x. Then we can solve for x, which gives us a range. So the first step is to find out the common ratio. To find the common ratio r, we simply divide any term by the term that came before it. So let's take the second term, t2, and divide it by the first term, t1. So t2 is 3x over 2, and t1 is 1. So we have 3x over 2. So our common ratio r is 3x over 2. We can quickly double check this by dividing the third term by the second term, and you will get the same result. Now, once we have the common ratio, we can apply the converge condition. So step 2 is to apply the converge condition. So we'll substitute the value of r into this inequality. Then we get the absolute value of 3x over 2 is less than 1. So the next step is to solve this inequality. The absolute value of something less than 1 means that something must be between negative 1 and positive 1. To isolate x, we need to multiply all three parts of this inequality by 2 over 3. So we have 2 over 3 times minus 1. Here we also times 2 over 3. And on the right side, we also multiply 2 over 3. So we have this 2 cancels out this 2. This 3 cancels out this 3. So we have x greater than negative 2 over 3 less than 2 over 3. This inequality tells us the range of x for which our geometric series will converge. So as long as x is strictly between negative 2 over 3 and positive 2 over 3, our infinite series will have a finite sum. If x is equal to either of these two endpoints, the absolute value of the common ratio will become 1. And then the series will start diverging. And then we won't be able to get a finite sum. Alright, let's then calculate the sum when x equals to 1 over 3. You see that 1 over 3 is within this range that makes this geometric series converge. So we'll get a finite sum. The formula to evaluate the sum of an infinite geometric series is S infinite equals A divided by 1 minus R. A is the value of the first term, and R is the common ratio. So it is quite obvious that A equals to 1. So the first term is 1. The common ratio R equals to 3x over 2. We got it here. So when x is 1 over 3, we have 3 times 1 over 3 divided by 2. It equals 1 over 2. Let's now substitute the values into the formula. We have S infinity equals to 1 divided by 1 minus 1 over 2, which equals 1 divided by 1 over 2. So eventually we have S infinity equals 2. So when x is 1 over 3, this infinite series converges to a finite sum of 2.